Hello, Battlesnake friends. It is Aurora and Alec back again. I'm Aurora from Battlesnake, and this is Alec from New Relic. If you've had a chance, if you haven't had a chance yet, do check out our previous video, which was a quick start on how to instrument your Battlesnake with New Relic. That is the foundation knowledge for this one, where we're going to kind of take it the next step. You know, you've got your basic dashboard set up, you've got some New Relic monitoring, but how do you customize this and debug and solve problems with your Battlesnake? So that's the big question here. So Alec, you have a Battlesnake ready. It's competitive.
Yeah, it's competitive. It's not. It appears to be having some problems though.
Oh man. Okay. So let's see how we can use a New Relic dashboard to help us identify some problems and maybe do some customization to really see what's going on and get that little bit of extra information from us.
Absolutely. Let's get into it.
Cool.
All right. So I think we can show off this game we just played here.
Nice. It's sort of natural setup. You're battlesnaking as you do.
Of course, yeah. Just casually just sitting here watching some Battlesnake games, and I don't know if everyone saw that there, but if we go back a lot of turns, we'll see that my snake here, Shaihalud, just decided to turn up and then drive itself directly into the wall. Which is not so great.
Yeah, we're seeing that 500 millisecond. I mean, if this was a Battlesnake tournament game, Curtis would be saying right now, we hate to see it. We hate to see Battlesnake timing out and running off the edge of the board.
Never what you want to see. It's like the saddest failure you can get there.
Tell us about your Battlesnake. Should this be happening? What kind of Battlesnake do you have running right now?
Yeah, no, it definitely shouldn't be happening. Although it is possible to be happening. Yeah, I have it running with a min-max search for the game tree, deciding on which moves to make. It's a game theory algorithm. There's lots of resources out there on how that works that you can go check out. And then I also have alpha beta pruning implemented on that to just allow it to be a little bit more performant. And then I have put a little bit of work into going into iterative deepening, but it is very much at the beginning stages. So it's possible to have a higher timeout, but the majority of this time, my response time should be limited to under 200 milliseconds. So this is very surprising to see.
Yeah, seeing these spikes to 500. And absolutely. So min-max, you've been working on your Battlesnake. You're no fool. You're no stranger. And there's a great community blog post that I will link to in the video description about what min-max is and what alpha beta pruning is and how to sort of run these algorithms within your 500 milliseconds. So assuming you've done all that, you think you've done everything right. So why are we seeing these 500 millisecond timeouts? This is the mystery we want to solve.
Right. So now is where, New Relic can come in and actually give you some in-depth information as to how your Battlesnake is executing while it's out there running through games. Come over to our service or, snake, Shaihalud over here in New Relic. We can see that we're getting some fairly high response times recently.
Oh, yeah.
It's hitting closer to 300, and I would expect we might see some 500s coming in as well. But if you're looking at this just with its base value, there's not a lot of information as to where this is happening and what's causing it. So here you'll see we actually do have a detected 2.92 second response time for one of the move requests, which is a bit higher than we'd want it to be.
Yeah.
So here we can see some basic information about that transaction that was 2.92 seconds long here, and you can see it's sending out some logs to New Relic. It's got some some basic HTTP endpoint stuff going on. It's got the JSON parser, it's got the post request, but it doesn't give us really any in-depth information as to what your Battlesnake's algorithm is doing here. And unfortunately, those are hard things to instrument because everybody's code is different. So there's no automatic instrumentation for that. So you do have to go in and just add a little bit of more information to start digging into that, so that New Relic can pick up that information, and actually get down into your call stack, which is what we want to do here. We want to now take a look into this min-max algorithm and find out where exactly in that we are running into this slowdown.
Brilliant. Nice. So, I mean, we've got the scene set here. We've got a fairly, like a built-up Battlesnake, some that's had some love and some time in it, but we still have the default New Relic installations from the quick start. So let's enhance. How should we tackle that? What's your advice?
Yeah. So the first thing I would do there is basically add on to these transactions. So what we're going to want to do is basically go in and annotate functions to call them out when they're gone, when a transaction is recorded.
Nice.
So that we can do that with our Node.js's custom instrumentation here. So what we're going to actually go in and do is take these transactions that are automatically generated from your express endpoints, which are, slash for the info, start, move, and end, and go in and basically just at each function level that we want to track, basically just add an annotation to then make that part of what's recorded in New Relic.
Great. So you're showing us here the New Relic documentation for Node.js, custom instrumentation. Am I correct in assuming we've got custom instrumentation documentation for other programming languages as well?
Absolutely, yes. There's an option for this for pretty much every major programming language out there. And then a lot of it comes out of the box, especially with the more popular HTTP and web frameworks that are out there. Yeah, so here you'll see like our full-on guide for Node here. But what we're specifically looking for is, I can find it. We are looking specifically for starting a segment within one of our transactions. I just need to, here we are. So here we are. We can add basically what segment is, that function call or whatever that action is in your transaction that you want to keep track of. So here we're going to use New Relic start segment at each point within our code base that we want to track. So without further ado, I'm going to hop into the code and start annotating. So here we are in the index file for our application. This is index.ts. This is where we have our express endpoints, slash for info, start, move, and end, and the standard ones for any Battlesnake. These are automatically instrumented, which we saw earlier when we were looking at the transactions, and we saw that 2.92 second, I think, long move request, which is, a bit over the 500 milliseconds that's required. So what we can go now do is move into our move function, which is right here over in our logic file. And we see we have our move request here. This is also standard from the starter Battlesnake for TypeScript. You'll see the same function name, same structure here as well. And so right here, I have my determine move function. This is taking in the current state of the game and the number of iterations that I'd like to go into my algorithm for testing these things. And so what we're going to do is add one of those segments in here. So we can do New Relic, make sure I actually imported that. I imported it as NR.
Cool.
So what we can just do is this. We can do nr.start segment. And then this is going to take in a name for the segment. So in this case, we're going to call it determine move. Again, these are going to be called on every single time one of these functions are called, so you don't want to use any kind of variable that's going to change when you name these segments. You're going to want like a very static one, because what you'll see is this will allow us to look at these segments over time as well and see how like that specific part of the segment has changed, which could be very helpful. So we'll say we do want to treat it as a metric within New Relic. That's what the true is saying there. And then this is the callback function that's actually going to run, the code we want to execute here. And awesome. That will properly return that back up to our variable here. So there we are, nice little bit of auto formatting. Now we have the first segment within our transaction. So this will be the determine move segment. To get more in-depth information, we're now going to want to go into determine move. Please ignore my large amounts of comment and no code here. It's active development.
In progress. Yeah.
Yes. So then we can go in here and start kind of working our way down the tree of code execution and adding in our segments. So we can do NR, if I remember correctly. start segment, and then this is going to be our iterative deepening min-max. We're going to make it that a metric.
Nice.
There we go.
Because we did the setup already with the quick start and we like got the default New Relic components like integrated in, now we've got that whole library available to us to start starting these segments and like popping them on functions we want to specifically monitor. So very smooth. And a good practice, I mean, I like this too. I would do this as well, where I would just be naming them literally the name of the function. Like I'm probably not going to change that.
Oh yeah, that definitely helps out a lot. Just to allow yourself to map it back to the code base. It's always useful there. Toss another one here. Sorry, this is of course super exciting live.
Yeah. No, we got like three or four functions down here, just piping through there, wanting to monitor them individually. And for anyone doing this with their own Battlesnake, I mean, of course, whatever functions you have written, this might also be a good opportunity to do a review of your own code. If you've ended up with some mono functions that are just responsible for too much, this might be a good motivation for sort of breaking it up and modularizing it so you can monitor the different components independently and really help with your debugging. It's just good coding practice, you know, but it helps to have a motivator sometimes.
Absolutely, yeah, because you'll see here I have some very large functions, and they tend to start getting in the way, especially once you get to this point and you're starting to make these kinds of changes. Like having that bit of organization can really help a lot. And with my future iterations, I know I'm going to be organizing a lot better in the future.
I mean, code's a living thing, right? You don't write it perfect the first time. You start writing it and refactoring and just adjusting, and it lives and grows and is organic as you realize what you want to monitor, what you don't, how you want to break it up. It's not perfect the first time. We grow together, us and the code.
Exactly. All right, almost done with these.
When you're doing a start segment, do you need to do an end segment function call or just start?
Great question. You do not need to do a end segment. These are automatically being added onto those segments I was talking, the transactions I was talking about earlier that are automatically generated from the express endpoints that we have. And when you have those web requests coming in, all we're doing is basically just adding a segment, which will be the execution of the function I have passed as the callback here.
Awesome.
So there's no need to call an end or anything like that there, which makes it much easier in something like this that is a recursive function.
Yeah. And for a lot of Battlesnake folks who are reaching sort of that level of competition and development of their Battlesnake, they're probably in a similar situation. So this is very applicable. Like you can start adding this to your Battlesnake today and just get that extra insight above and beyond what the default New Relic Battlesnake dashboards give you.
Yeah, so then an overview of where I am currently. I went in and added the start segment to all of the calls to my min-max function. Now just going to go and add it a segment on my heuristic functions as well. I have one for the current state of the game at the end, or at the end of my depth, and then I have one for the current path run as well, just to detect anything bad in front of you. So we're just going to, because those do, in my experience, have the tendency to be where I spend the most of my time when I'm executing, a move request. So I'm going to add something for those as well. And this way we'll get a full view into the execution of a move.
Nice.
There we go. One more. If I can spell.
Heuristic is a complex word. Yeah.
Oh God, I know. That one's got me so many times. I'm like, you are. Yeah. All right. So now we have basically this set up for the majority of the bigger function calls that we're making when deciding to move. So if we're the maximizing player, that's a min max thing. Don't worry about too much about it. But you'll see we'll go in here, we'll loop through the number of moves, and then we'll go get the path heuristic, which we have the segment on, and then we'll also make our next call into min-max here, which is also being tracked by a segment. So what's nice is once we get to see the new relic, we'll be able to see the actual execution tree going down through this recursive program, which I think helps make it easier to reason about.
Nice.
Yeah, so let's get this pushed up and deployed, and we can go try to figure out why we're getting those 500 response or 2.9 second response times.
2.9 is too many. 500 milliseconds for Battlesnake. All right. So let's get this code uploaded, deployed. I mean, don't forget, this is just a reminder when you're making changes to your Battlesnake, and especially when you're adding new monitoring, you will have to get it deployed, get it out there, start playing some test games, or maybe if you're set up in sort of like a competition or otherwise, maybe some games will be running automatically for you. Cool.
Okay. Okay, we just need to give that a moment to deploy here.
Okay, so getting a deploy through, which takes a few seconds there, but we've got a Battlesnake. It's updated. It's now has segments tracked on a whole bunch of its functions, so we can dive in and identify what this 500 millisecond timeout situation is. So let's see. Let's see what the dashboards tell us.
All right. Yeah, so we've got here, we can see some of our super high response times. We've got like this 520 millisecond. It looks like we have another one that's getting close to that as well. So now that we've added in those extra segments, if we go down to something like where we looked before, where we have these really long move requests down here, we have this slow one coming in now at 3 seconds long. We can now click into that one and get a little bit more information on it. So here we have like the actual request that it took 3 seconds. But the thing is, now we can go get more information on this overall request to the system by going down over here to distributed tracing and selecting our move transaction here. And we can actually see that we recently had a game run 2 minutes ago, and we'll see we have 410 spans here versus ones that like only have one span. These are the ones that have come in since we added our start segments because they have a lot more going on. So now we can see we have this nice timeline view of the transaction as it goes through like that. And then you'll see that it doesn't by default display the in-process spans because a lot of what distributed tracing is for is also tracking between services. So if you're running a microservice architecture, so you'll see a lot of it around that. But it still totally allows us to completely dig into a function trace and the stack and the stack as it goes down through the code. So we'll see here, we have our determine move call after some of the setup boilerplate stuff.
It's all the segments you put in, those names you typed.
Here they are, and it doesn't look like I misspelled any of them, surprisingly.
Nice.
So we'll come in here. We'll see like here's our determine move. This one took 115 milliseconds, not too bad. Overall, this is probably not the best one to be looking at, even it's here because this one did respond in time. So let's go back out and find a transaction that was a little bit over what we're expecting, because this one looks like everything was just fine.
Yeah, I mean, especially when you've got like an intermittent issue like this where it's not happening every time, like you want to look at exactly how your server was behaving in the game that it misbehaved.
Yeah, and I think this kind of tracking helps a lot, when it comes to those kind of errors that you're not going to hit very often. Like I said, like that garbage collection error that I had run into on mine that I only found out because I literally went in and looked at the garbage collection time for the node VM during execution. Some of those are very hard to determine on any, like, especially on something that's not running on your computer and not running locally, makes it a lot more complicated. So yeah, here's one. We know this trace took about a full minute, so that's too long. So this will be a good one for us to look into. We should be responding in less than half that time.
Yeah.
And you'll notice here we see once again, our waterfall view of the request. Yeah, and as we come down here to determine move, we'll see it's, about an IDS min-max, min-max. We've got the path heuristic for that call. And then we've got, the next recursive call min-max. So you can kind of just watch this go down here as it runs through. And this is the parent for everything under it. So that's why you see it ran this long. That's how long that part of the transaction took. But what we do notice here is we see some stuff around, say, the state heuristic here running at 0.42 milliseconds, and then we've got another one here running at 0.67 milliseconds, that seems reasonable, right?
Yeah.
But then if we scroll down here a bit, we'll see we have state heuristic coming in at 334 milliseconds. And you'll also notice New Relic even comes in here and tells you this is weird. Weird behavior here. It's this is much slower than the average, so you should be looking at this. So that's what they're telling us there. And as we scroll through here, I think we'll see that that is probably the only outlier here. We have another call out here at 200 milliseconds for that function. But we'll come over here and see the more normal runs at, a little under 1 millisecond.
Very suspicious.
So, yeah. So at this point, I am very, very interested in state heuristic and what it's doing randomly sometimes to mess with our response time. So the next step that I can do is I can actually click into one of these parts, one of these segments, and I can actually see the average response time and the throughput of that function over time. So because I added those segments in for every single request, it's going in and tracking that information. So now I can actually look at the average response time of just the state heuristic function over time. So you'll see we get some stuff around 2 milliseconds, and then we also have stuff with 4 milliseconds. I think we're just waiting on some of these higher and slower ones to come in to this view here, but you'll be able to actually track these things over time. So here we have our duration histogram where we're hitting this the majority of our requests are in the 0.3 to 0.6 millisecond range. But we do have some huge outliers here coming in at over 5. Excuse me.
Yeah, no, nice. So just scrolling through, especially if you've got a recursive function, there's a lot of calls, seeing these averages and these visualizations it's just a huge help, right? Rather than trying to, print statement log your way out of this problem.
The print statement logs with recursive programs can get very hairy very quick. So yes, it's definitely, I highly recommend it. It's a great way to get in and really understand, what your algorithm's doing under the hood without having to pour through a massive output file to figure it out. So yeah, now that we know that mainly this function is, as far as we can tell, doing some anomalous, I'm not gonna be able to pronounce that word.
It's misbehaving.
It's misbehaving. It's a much easier way to much easier to pronounce. Yes, it is definitely what is misbehaving here. So now we can go check out that function and see if there's anything weird going on there.
Nice. Shall we switch to the code?
Yes, please.
Obviously, New Relic with the quick start guides ships with a whole bunch of default Battlesnake dashboards. But now, as we sort of move through and use some of the more generic New Relic content, you can start kind of customizing, adding your own data, and just sort of seeing what do you want to monitor, what do you want to track, what's normal, what's not normal. Maybe learn something. Even there might not be anything wrong. This might be a really good opportunity to understand what parts of your code are taking time. Maybe there's places you can do optimizations. So this is a great example for a bug, but there's lots of opportunities here with this information displayed in this way.
Oh yeah, I had situations where at the first turn of the game, I, go past 500 milliseconds because every snake has, 4 different directions it can go versus the normal 3. And, so I'll stop, I won't respond. It'll have to kickstart for the next round. You can definitely run into stuff like that. And, having that tracking and that extra information in there can be really useful. You can even start going in and adding, other things to these transactions around, how deep did you go in your recursion? How many opponents were there? How many move options were there? And you can get a lot of that information and start tracking that over time if you'd like to.
I mean, that's a really good point. I know of a lot of folks running algorithms where the more opponents they have, they realize the worse the performance gets, but that might not be obvious. So tracking that can be very helpful to help surface that information.
Absolutely.
All right, let's find this problem code.
Yeah. Okay. So I'm back in my index.ts file. So we're back here where the routes are. Yeah. And so we're just going to start stepping into this. First, let's go into our move function here. So we're at the move function where we added our first start segment. This is the determined move one. So we're just going to start following this tree down, and then we just now need to go find our wonderful state heuristic function. I'm just going to minimize that. So here we are. We got our state heuristics. So this function, it's doing some math along with just checking to see if the game is over and did we win or did we lose. So yeah, from what I can see here, though, I'm not seeing anything that would immediately cause such a spike in response time. But what we could do is we could start looking. What the next step we could do here is start adding those segments to each one of these functions to start determining where that is. But at this point, I've whittled down the options enough that I would probably just start hopping into these functions. And if we were to then hop over here to is game over, that one looks fine. So we can go back. But then if we go over, did we win? We do see, looks like I left a 500 millisecond delay just sitting in here. And that may have something to do with why we're running into such
Who lets that
high
happen,
response
Alec?
times, right? Yeah, let's get the commit history on that one real quick. So if
Check
I delete that there,
Git blame history there on that one. Yeah.
Right. We need to do some blame there. Yeah. And so after doing that, we should see our response times go back into like the 120 millisecond range, and then we should see our state heuristic function go back into that average that we were seeing before.
Yeah. I mean, so obviously this is like a very contrived, example.
Oh, absolutely.
But I mean, what this does do is like your code base has gotten rather large over time, right? Like you have a lot going on, you've got the recursion. So even just having this help us narrow down to like what portions of my code should I be focusing on? Where should I be adding more monitoring or adding more information? I mean, this is just a huge help for getting to the debugging. Cool.
Right, because and I chose the that function there, the did we win function, just because like those are hard ones to figure out when you start seeing response times like that, because they're so buried. It's not even part of like the main algorithm. It's just a check that's run at like certain times, and it's without like going through and starting to like log out response times for each function, you're not going to be able to figure that out without literally stepping through every piece of code in your code base. So this, yeah, exactly like you were saying, this allows you to whittle down the options very quickly.
Brilliant. Awesome. So, I mean, this is a really great example about how we can sort of take one approach with the segments in New Relic. But are there other recommendations like for upgrading our Battlesnake and how we can kind of get more information to help us in our building and our monitoring of our system?
Yeah, absolutely. I especially have some recommendations around, monitoring and just making sure your snake is like ready for tournaments when they come around and ready for the league. And those are mainly New Relic alerting and New Relic synthetics. We highly recommend you set those up. Synthetics are just a very quick way to ping your application, make sure it's still up and running, and just have that confidence that your snake's not just randomly going down at 1 a.m. or something like that. So you can go in and set those up and just set it to just ping your info endpoint real quick and just determine that your snake is up there and running. And that way that at any point in time the snake is there, it's ready to respond to requests. And then combined with that, you can pull in New Relic alerting, which will allow you to then take those synthetic responses and actually either, like, I think the default is you can send an email to yourself if you'd like to, but you can also send it to Slack, you could send it to PagerDuty, you could send whatever you'd like, but basically you can set up a little alert condition that says, if my synthetic check is failing, then I need to go alert someone. Most likely you, unless you got a full team working on your Battlesnake. So then that allows you to just receive that notification at any time. So like I have mine set up to go through PagerDuty, so I get alerted on my phone. But there are many different ways you can go about doing that. Yeah, and then I also wanted to say about alerting. There's not all like you don't just have to do is it up or down alerts. You can also go in and do alerting on, say, your response time. So, you could say, over a, 1 hour period is my average response time, ever going above, 400 milliseconds, just to be safe. And then you could alert on that. And you can also set up things. Exactly. Yeah. Get that whole threshold in there. And there's some out of the box monitoring that happens there with New Relic incident intelligence that will, keep track and see if there's any like big anomalous changes. We saw that where it was auto detecting that the state heuristic function was out of whack. So that's something that can really help with. And then one last thing, alerting can also be used for things like if you're throwing errors, like I said, response time already, and then pretty much anything around that, anything you can be collecting metrics on, even if you want to send out a custom metric. So like you could take the information returned from the game end request and alert whenever you lose a game. I don't recommend that because I lose way more games than I win. So I do not need to alert every time that happens. But you have a lot of options out there to really, be confident in your snake and have it ready for anything.
Nice. Yeah. And I mean, it's such a great opportunity. I mean, like throwing your 3 a.m. alarm on your Battlesnake might feel a little overkill, but it's an incredible way to sort of practice using New Relic. So we actually use New Relic to monitor our Battlesnake main servers and are using a lot of these same tools, right, of tracking, keeping information. I was using it to debug a problem last week where we had a database query that was taking a long time, and just being able to identify exactly where that was being triggered because it was off on a separate, worker agent, right? So, I mean, this is a great opportunity. Instrumenting your Battlesnake with New Relic just gives you a chance to take that learning aspect, and you're like, well, sure, I'm Battlesnaking, sure, I'm competing, but I'm also getting practice, using in a production live environment how to use these tools, which is just good for your career development.
Yeah, absolutely. That jump from I know when I instrumented my first, piece of software, and that jump from I go look at logs on a server somewhere to it's all in a system that has, performance stuff on there too, and all the information you need. It's a kind of an eye-opening experience for sure.
Yeah, absolutely. That's brilliant. Well, is there anything else for folks who are now trying to, bring New Relic into their Battlesnake, maybe it's taking it to the next level? Any kind of closing thoughts or suggestions or tools?
Well, I would first of all, oh, sorry.
No.
Yeah, I would. I think I would just say, try it out. Once again, you can try out New Relic totally for free. You won't run into any limits that require a credit card till later on, and also you can keep using New Relic without a credit card. You'll have a limit set at the end of the month or something like that. But you can basically get up and running with everything we've gone over in these last 2 videos. Without paying a dime to start off at least. And there you go.
That's brilliant.
I say just get started, try it out. That's all you can do.
Mm-hmm. Mm-hmm. And a good excuse on your Battlesnake. There's some motivation there.
Absolutely.
Brilliant. Well, Alec, thank you so much for spending time with us, walking through your Battlesnake debugging, showing us how we can use New Relic to kind of bring it to that next level. So for those of you who are Battlesnaking, don't forget to check out if you're interested in using New Relic and you want to talk with other Battlesnake developers. We've got resources at docs.battlesnake.com for your Battlesnake work. And definitely check out Twitch and the blog for extra posts and information, as well as our Discord. Talk about if you're using New Relic. Let us know what you're doing, what problems you're solving, maybe what information you're tracking that's proving to be very interesting and advantageous. The community would love to know. But that does this. This is using New Relic with your Battlesnake. Thank you again so much, Alec, and we'll see you all on the flip side.
Thank you. Happy to be here.